Hey everybody, welcome to office hours for the How to Code Simple Data and Complex Data courses. I hope everybody's doing great. And why don't we just go ahead and jump in? We've got one question so far for this week, so I will jump to that now. Let me do my screen share. And I go here, no here. Let me make this go away. And here's the question. Nope, here's not the question. And here's the question. The question has to do with Big Bang and the relationship between the xxx's in the parameter, the xxx parameter, and the first argument to Big Bang. So let's jump over here and look at an actual case of this. So what's going on is that main consumes a parameter, can be called anything, and hands it directly to Big Bang. And that's usually the way we do it. Okay? And because sometimes that parameter can be complicated, we often put a comment right here above the main saying, look, the way to start this thing, oops, that's not what I wanted to do. The way to start this thing is to call main with that. So all that's really going on is we're just saying, look, by convention, whatever you call main with, you also call Big Bang with. Of course, it doesn't have to be that way, right? You could say, well, you know, the cat's always moving to the right. But we'll change main so that main just gets a number, which is the cat's x position, and then it does something like make cow. We just rename the parameter x position just to help us understand it. It doesn't really matter, of course, what we call it. And there's a slightly different version of main. And now when I call main, I'm supposed to give a starting x position, like I could give 50. And now the cow. 50 wasn't a big enough number. Let me try it again. Main 200. Now the cow starts out right in the middle of the screen. So all that was really going on, let me back this out to the way it was before. Cow. C. All that's really going on is that by convention, whatever we give main as an argument, it hands directly to Big Bang. Now what you would really do, here's what you would really do. For a thing like this, where really there is probably a best place for the cow to usually start, it would use a feature that doesn't actually exist in BSL or ISL, but it does exist in advanced student language. Well, where did it go? It does exist in advanced student language, and here's the feature. I don't know what that was about. Okay, so all I've done so far is to turn on advanced student language. But now that advanced student language is turned on, I can make a function that doesn't consume any arguments at all. And so main consumes no arguments, and it's going to basically say, oh yeah, but we're going to start with this cow every time. So what the heck is a function with no arguments? And why does it only exist in advanced student language? Well, a function with no arguments is a weird thing, because if it's truly a function and it doesn't take any arguments, then it will always produce the same result. Because after all, a function is just a function of its arguments. But Big Bang has user input coming in from the keyboard and the mouse. So in a funny way, once Big Bang starts running, there are additional inputs. The additional inputs are what the actions that the user takes. So it sort of makes sense to use a main with no arguments to call Big Bang, because even though this will always start with the same cow, once the user starts pressing the key, the program will actually have different behavior. So to back it all the way out, by convention, in the preliminary languages, we always just make Big Bang consume the same type as the world state, just so that all our main functions look the same. But it doesn't have to be that way. It's nothing more than a convention. And if you really wanted to do it more the way you do it in a full-scale programming language, you would actually probably make a main of 0 arguments like this. It just says always start with the same. Excuse me, always start with the same initial state. And to be honest, you probably wouldn't even do that. You'd probably do something like have some initial cow appear in your constants. Well, 0 or something, which would be make cow 0, 3. And then you use that cow 0 here. I'm having a struggle with typing on the keyboard today. Like that. Okay, that addresses this question in as many forms as I can think of to do right now. Do we have any other questions come in?
The person watching said that answered their question, and they didn't have follow-ups. I'm just going to refresh the page. No more questions.
And do we have any HTC1 questions?
Nope.
Okay, well, again, all I can do is answer the questions that you asked.
Here we go. Sorry, one more.
Okay, so the question is, has to do with some difficulties in making movements in world programs and what suggestions I kind of make. So a thing that often happens at this point in the course is that, and actually this happens at many points in the course as we go through, is that people, particularly people who kind of already knew how to program, but not always people who already knew how to program, you know, maybe kind of got the hang of the preliminary material, but didn't completely master it. And now all at once the programs are more complicated and some old problems come back to haunt you. So I guess I would say this, if you're having difficulties thinking about making things move, so let me just back this all the way out. Let me go all the way back to cow, and then C, and then C, and I'll set this back in intermediate student language. And run it. The main suggestion I would make to you is be careful not to skip the early steps in the design method. In particular, you got to do the whole HTDW process. And let me just go to the whole HTDW process here. We'll go to design recipes. And we'll go, I like to use this, do we not put the cheat sheet on that page? The summary sheet? Oh, here it is, right here.
There you go.
I like to use this summary sheet. So for HTTW, you start with the domain analysis on a piece of paper. Okay. And so in particular, you identify, in this case, that the screen width and height don't change. And maybe maybe there's two different images of the cow, but those images don't change. And then you identify the changing information. And in this program, that's the position of the cow and the direction of the cow. And then you identify the Big Bang options. Well, in this case, something changes with time, so you're going to use onTick. You're going to display an image, so you're going to use toDraw. And you're going to change the direction of the cow when you press the key, so that's onKey. And so at that point, you've got some notes here that kind of say, well, constants are width, height, and the usual constants. Changing information is the X position and the direction, and the Big Bang options are onTick, toDraw, and onKey. And then again, going slowly, you jump over here and you do your constants, and you try to pick up every single constant from your analysis. And here, this one's a little bit fancy. In order to make it look like the cows are walking, we kind of make a bunch of different cow images that look like the cow is rocking back and forth. You didn't have to do this. You didn't have to do this fanciness here. You could have just done that. It would have been fine. Okay? Certainly in your first version of the program, you wouldn't do this fanciness. In your first version of the program, you might not even have two different cows. You might just have one cow. And then you have to figure out how you're going to represent the changing information. You use the full HTDW recipe, the full HTTD recipe. So let's see, in this program, the changing information is two values. The X position and the direction. And so it's two values that go together in the world state. So that gets you a compound data definition. And there it is. Cow is X and DX. You could call these anything you want. You could call that world state, X, direction. But the key thing is it's compound information because there's two values that go together to comprise the world state. You follow the whole HTTD recipe to get the type comment, the interpretation, some examples, and a template. And then you can really pause and go back to your domain analysis, go back to the picture that you made, and say, did I capture everything? Do I have all the constants? And can I represent, using make cows, can I represent different configurations of the game? And only when you're comfortable with all that, then you go back to the rest of HTDW, and you do the main function. And I think if you do it that way, I think if you have the patience to do the HTDW recipe really carefully and the DD recipe really carefully, I think you'll end up having a lot less problems, because by the time you get here to next cow, let's think about what your template's going to be. You'll have written maybe template from cow, and you'll have gone to get this template here. And you'll rename that template to next cow. And staring you right in the eye, right here, will be a reminder, oh, cows are compound data. Cows have an X and a DX. And then I think you won't have anywhere near as much trouble. You'll still almost certainly have some little bugs. You'll definitely have little bugs. You're always going to have bugs. But I think the basic shape of what it has to be will be more clear, and you should have fewer problems. Does that help? Sassy is checking in with the person who asked the question. I'll just give you guys an interesting side point while we wait to see if there's a follow-up question. I don't know. I'm just mentioning this for just to let you know. Every year, edX has a conference called the edX Global Forum, where all the schools and other partners that form edX get together. And this year, actually, UBC has the privilege of hosting it, and that's actually starting Monday at Whistler Mountain near here. So it's going to be fun because we're going to be getting together with all of our edX colleagues from universities around the world for a couple days to see the interesting things that people are doing. And I think we're going to hear a lot about different MicroMasters programs. Let's see, we got an answer back. Yep, that's right. Less time on the main function, more time on HTTD and HTTW. So I think I will leave it with that. One thing I will say to people who are maybe reluctant about asking questions is, they're all good questions. Never be reluctant to ask a question. I know it's a little difficult in this course because some people are kind of doing week 2 while other people are doing week 12. Don't worry about it. The people who are doing week 12, back when they were doing week 2, they had the questions that you have, and they'll appreciate you asking them. So, ask away. It's fun for me to get together and talk to you guys and answer them. And in absence of anything else, I think we'll leave it there, and we'll see you.
To schedule the next one still.
We have to schedule the next one still. We'll probably do one more before the UBC's winter break, and then we'll get back to you. But we'll get back to you on the schedule for the one more shortly. Thanks a lot. Bye.